This is now video 4 for our chapter 11 in this textbook, and we are way down here now on 13, the iPhone layered approach. Now, very similarly to the way Android worked, Android has a layered approach, or has a layered approach, I should say. The iPhone also has a layered approach, but it's interesting, the names that you see in your textbook aren't really the same as the standard names that Apple puts out. So I put them both side by side so that you could sort of compare them. And in fact, in this first case, the system architecture layer, there are really two different layers, the system security layer and the hardware and biometric layer that it corresponds to from the Apple white paper. I'll show you that Apple white paper. In fact, it's this link right here, and it is this white paper right here. And you can see it goes through each of these and gives you a lot of detail about what each of these layers does. But the concept is the same as the layers in the Android. The idea is that when an application wants to access something, it has to go to that layer and ask for permission to access it. And then that layer in turn will access the hardware or whatever modules it needs to access in order to perform it. And I'm not going to walk through all of these, but I'll just put them here for you to see: system architecture, encryption and data protection, network security, application security, internet services, and device access. There are also abstraction layers at a higher level. In this case, these are the operating system abstraction layers. And they have a layer called the Cocoa Touch layer. I should have bolded that. The media layer, the core services layer, and the core OS layer. And I'll let you read through those. I don't want to dwell on them right now because it wouldn't be very helpful, I don't think. You can read what they do if you want, but you get the concept again that the applications have to go to the layer in order to ask for something. In this case, they're going to this layer, and then this layer is in turn going to this layer, which is then in turn going to the hardware or whatever it needs to go to in order to perform that function. We had a list of 20 vulnerabilities for the Android, and we have very similar ones here for the iPhone. Some of these are the same, and some of them are self-explanatory. You will probably already know what a zero-day exploit is. If not, you can read that here. SIM card swapping and jailbreaking. We've talked about all of these already. You know what a phishing attack is. You know what a malicious app is. You know what a Bluetooth exploit is. You know about Wi-Fi eavesdropping, location tracking. iMessage vulnerabilities. iMessage, if you're an Android user, you probably don't recognize that name, but it is the messaging system that is used in Apple phones and is vulnerable to some sorts of interception and unauthorized access. By the way, all of these in both the Android list and in the iPhone list have real-world examples of these attacks having occurred. So just so you know, these are not all just theoretical. Of course, you understand weak passwords and third-party app vulnerabilities. Of course, you're not supposed to be able to put a third-party app on an iPhone unless it's in the store, right? Whatever they call it, the web app, or what do they call it? The app store. So these are vulnerabilities that occur if the app wasn't built properly and vetted properly, or if you jailbreak the thing and put on a third-party app that was not in the app store. Email vulnerabilities, again, this is usually having to do with social engineering, outdated software you just don't keep up to date to get all the bugs out. Type confusion bugs, issues in memory management that can lead to arbitrary code execution. Now, unless you're a programmer, you may not understand exactly what a type confusion is, but a type has to do with variables in your program. So let's say I have a variable x that could represent some text, a string of text, we call that a string, or it could represent a numeric variable, for example, an integer or a floating decimal number. There are several types of numeric types. So that's what we mean there by type confusion. In the programming, the type is not clear, and so it confuses things. USB exploits, pretty obvious, USB connections. WebKit vulnerabilities, flaws in the browser engine that could lead to code execution or data leakage. Insecure APIs, we described that one under the Android section, so I'm not going to go back into that. Of course, social engineering attacks are obvious. Data leakage from apps. This is, of course, like we talked about before, where you have data in your phone and you carry it around and it leaks out, say, outside the workplace. or simply data that should be kept private in your phone, such as your contact list, that gets leaked out somehow. And then advanced persistent threats. These are attacks that use very sophisticated code in order to stay on devices and be persistent. In other words, they remain on the device and they continue to attack it, usually unbeknownst to the user. Last but not least, Windows phones. Well, they are out the window. There's a section in your chapter on Windows phones, and I am skipping it because as of December 10, 2019, Microsoft retired the Windows Phone and is not making any more. So that's it for Chapter 11 for this week. Thank you.